Hi, we'll start very shortly, but if you have certain doubts, any questions, anything to ask, this might be the time to ask. We'll start in just 1 or 2 more minutes. Also, please just type in a comment to let me know if you can hear my voice. Okay, thanks, Abhay. So today's agenda is we'll introduce the some concepts related to speed, distance, and time. We'll do some questions. The difficulty of the questions won't be very high, and we would leave a few topics for next time. So we have divided the speed, distance, and time topic into 2 sessions. Uh, Tomorrow we would not tomorrow, the next session we would look into circular motion, clocks and those kind of things, plus we'll do a lot of difficult questions. Today we'll just go through some of the more basic material, plus there are some good questions also in here. Abhay, I don't get your second comment, your WC sir. I don't get what you mean by that. So this is pretty basic stuff. Speed is equal to distance by time. I think most of you know the formula. Distance is equal to speed into time. We won't spend time on this. You probably know this, right? So let's move on. And before we move on, yeah. So one thing you should know is how to convert across units, kilometer per hour to meter per second. Both are fairly used units, so you should know how to convert from one to the other. Let's just look at the derivation. So, and most of you know anyway, but we can again go through it. 1 kilometer per hour is equal to 1000 meters by 3600 seconds. And if you cancel everything, this will come to 5 by 18 meter per second, right? Or 1 meter per second will come to 18 by 5 kilometer per hour. So this is the method to convert. You can just multiply by 5 by 18 or 18 by 5, depending on which direction you are going in. So if you have 18 kilometers per hour and you need to convert it into meter per second, you will just multiply it by 5 by 18. And you get the meter per second, which is 5 meter per second. And the same way, vice versa. If you have 20 meter per second and you need to convert it into kilometer per hour, you'll just do 20 into 18 by 5. And that's 72 kilometer per hour. So most of you know this, but still good thing to remember. 5 by 18 and 18 by 5. So we'll move on. So let's get started. From the formula, you should know this thing. If speed is equal to distance by time, you should know speed is proportional to distance if time is constant. Speed is inversely proportional to time if distance is constant. Seems fairly basic, but many times when an application comes, people do get confused and start going through very long methods or doing stuff which is not very straightforward. So we'll quickly look at a few questions which are down here just to see how you can apply this concept. Let's just I'll spend a couple of minutes explaining this also. So what I mean here is, if speed is proportional to distance by keeping time constant, what does it mean? So if there are two vehicles, both have a different speed. Let's say one is traveling at 40, the another is traveling at 30 meter per second. And if both of them travel for 1 hour, I have kept time constant. If both travel for 1 hour, then their distance will be on the same ratio. So the distance they travel will be in the ratio 4:3, right? So speed is directly proportional to distance. The one which has a higher speed will have a higher distance. The one which has a lower speed will have a lower distance, assuming time is constant, right? And the same way, it works in the opposite side. So if assuming distance is constant, assuming we have both vehicles, there are two vehicles, one is traveling at 40 meter per second and another is traveling at 30 meter per second, and both have to travel the same distance, what would be the time ratio be? So the time ratio would be inverse of this. So the time, if both have to travel distance d, then the ratio of time taken would be 30 is to 40. 30 being the time that 40 meter per second take, and 40 being time the 30 meter per second. So it's at the opposite way. How you applied, let's look at questions and then you will get it more clearly. So I'll start with the first question, and I put more on one page because I think we should go through them fairly quickly. If you are not able to get it right now, and I have said that many times before, you should later on wait, revise this video, and then you will get everything. So let's start with the first thing. If it takes 5 hours for a train to travel from Bombay to Pune, and if it takes 7 hours to drive from uh, uh, so it taking 5 hours for a train. So Bombay to Pune, the distance is the same. You can assume that. The question should ideally mention it because the tracks and road might differ. But and train takes 5 hours and driving takes 7 hours. So what we are being asked is, what is the ratio of train speed to car speed? So assuming distance is same, as we have noticed, speed is inversely proportional to time. So if the time ratio is 5:7, the distance ratio would be 7:5. So the train is 7 by 5 times what the car is. So if the car speed had been given, if the car were traveling at 100 km per hour, the train is probably traveling at 140 km per hour. Okay. In case you guys have doubts, please raise them in the questions and I'll take them. If I travel 60% more than my regular office commute, it takes me 1 hour extra. So here what I am saying is that every day I travel distance d, but if I travel 60% more, if I travel 1.6 d, it takes me 1 hour extra. So how much time does it take for my regular commute? Okay, so my speed is constant here. So the ratio d by t is constant. Now for 0.6d, which I have increased 60%. So for 0.6d, I take 1 hour. So you are being asked how much time does it take to travel d distance, which is my regular commute. So you can do very quickly d 1 by 0.6 or 5 by 3 hours. Okay, because here speed is constant. Speed is constant, d by t is constant. So for 1.6d, I take t plus 1 hour, and then you can subtract, or you can just say that for 0.6d, he takes 1 hour extra. So using that, I have just changed it to d to 5 by 3 hour. Okay. Same way, while traveling a certain distance, if I increase the speed of the car by 30%, I save 10 minutes. How much time does it take normally to cover the distance? So let's look at this one. Just move the other question down so I have more space. Yeah. So I travel a certain distance d. Okay. I travel a certain distance d. I have time t. I am increasing the speed of the car by 30% now. Okay. So my distance is constant here. So speed will be proportional to 1 by t, right? Or in a way, speed into time will be constant. So earlier, if I was traveling at speed s and taking time t, now I've increased the speed of the car by 30%. So now I'm traveling at 1.3 s, and the time I take is t minus 10. Okay. So now I have to say how much time does it take normally to cover the distance. So listen. Yeah, sorry, I got disconnected. So we can again, you can use this formula to get the t back. I'm extremely sorry for being disconnected. We had a minor tech issue over here. So even using this, you can directly get the answer. You can just cancel, and then you get t equal to 1.3 t minus 13, or then you can solve t equal to 13 by zero point 0.3. Okay, unless I have made a mistake. So that is how you can get it. Am I still not audible? I think I should be audible now. Right? I'm audible now, right? Yeah, sure. So this is how we can. You can try the last one also. It would be in a similar manner. Uh, So these are relatively straightforward. You just need to remember that speed is proportional to distance given time constant. Speed is proportional to inversely proportional to time given distance constant, and then you can adjust accordingly. So and it should take very less time. If you look at these questions and if you practice them a few times, it would take you very less time. Such questions get asked more in other exams. CAT might not ask very straightforward questions. They might ask also, but the chances are less. But other exams ask them a lot. So if you are thinking of appearing for them also, you might be able to go through these questions fairly quickly. Let's look at some race related questions. A beats B in a 200-meter race by 20 meters. What is the ratio of speed of A and speed of B? So how does the race happen? A and B will start at the same time. Okay. And it is A is beating B by 20 meters. So what it means is A is traveling 200 meters and B is traveling 180 meters in the same time interval. Right? That's how it is beating B. So here again, your time is constant. So speed is proportional to distance. So we know for the same amount of time, A is able to travel 200 meters and B is traveling only 180 meters. So if we want to know the ratio of speed of A to speed of B, we can just take the ratio of the distance they traveled, which is 200 by 180 or equal to 10 by 9. So don't get very confused with such question. If you actually know one person's speed, you can get the other one's speed also. Sometimes the question can be framed in a way that A beats B in 200-meter race by 20 meters. So how much would it be beat B in a say 800-meter race? So it's all directly proportional. So 200 meters, if it is defeated by 20 meters in a 200-meter race, in a 800-meter race, he would be defeated by 80 meters. Okay. Just you need to remember that in a race, mostly time will be kept constant. Okay. Let's see this. So A beats B by 10 meters and C by 20 meters. How much would B beat C in a 200-meter race? So what is happening here is that we have a race of, I think we should mention that it's a 100-meter race. It's a 100-meter race and A beats B by 10 meters and C by 20 meters. So in the time that A travels 100 meters, if A is here, B is only able to make 90 meters and C is only able to make 80 meters. So B makes only 90 meters. That's how A is defeating it by 10 meters here and then by 20 meters here. So from this, what we know is the time that B takes to go for 90 meters is the same time that C takes to go for 80 meters, right? So now we have to say what was the distance which B would beat C in a 200-meter race. So for the ratio here is 90 is to 80. So you just need to extrapolate that to 200 meters to get the answer. So you can just actually, if you want to get a better feel of it, this is 90 meters, 180 meters. So B would travel 180 meters while C would have taken only 60 meters, 160. So in the same ratio, if they continue, right? And then you can keep extrapolating and you'll get the answer as to 90 by 80 into 200. Sorry. So the ratio of the distance will be this. So the ratio would be 90 by 80 equal to 200 by x, right? And x will be the distance that c would have traveled. And so you can check for x and then subtract to get the answer. Yeah, so Ritam, what you're saying is correct. So relatively easy questions. The more difficult ones can also be framed, and we'll look at some of them in the next session. But this session, we are trying to expose you to these topics so that you are comfortable with them, so that in the next one you can very easily grasp the more difficult questions also. So let's look at this one. A bike runs at 25 meters per second and another bike runs at 35 meters per second. They both reach a destination together despite the first bike being ahead by 1 kilometer when starting. What was the total distance traveled by the slower bike? Okay. So here you can actually use relative speed also, which is like just the next topic. So it's a good segue here. So maybe we should use relative speed here rather than here. So what we are saying is there is a distance of 1 kilometer between two bikes. Let's say B2 and B1. B1 travels at 35 meters per second. Okay. And B2 travels at 25 meters per second. Now, and they are both going towards a certain destination. Okay, they're going towards a certain destination D. And what it says is that they reach this destination together and they start together as well. So what was the total distance D? This is what it wants to know. What was the total destination D? Now, we'll use relative velocity here. We can use, I think we can use speed time constant also, because they have been traveling for the same amount of time. That way also you can do. So let's try both. First, what we'll do is they both are traveling for the same time, right? Because they are reaching the destination together. So time is constant. Time constant. So speed into distance will be constant. So 35 into D will be equal to 25 into D minus 1, right? Sorry, D minus 1000, because you need to keep the unit same. So if the speed is in meter per second, we'll convert the 1 kilometer into meter per second. So D minus 1000. So you see what I have done here. I have just assumed time constant. So speed into time will be constant. So 35 meter per second, if it travels D, then 25 meter per second travels D minus 1000. So we have 35D equal to 25 D minus 1000. All right. And using this, you can solve for D. We can very quickly do it also. I just cancelled 5D minus 5000. Did I get something, miss something wrong? 25,000. Wait, I'm getting this negative, so I must have made some mistake somewhere. D cannot be negative, right? So, yeah, but D shouldn't be negative, right? 35 meter per second, the bike in behind is faster. And it will, sorry, distance, I've made a big blunder, extremely sorry. Time is constant, right? So sorry, speed is equal to distance by time. If time is constant, distance by speed should be constant. Yeah, sorry, completely distance by speed would be constant. So assuming time is constant, so D by 35 equal to D minus 1000 by 25. Okay, extremely sorry for that. So this is 7, this is 5, and then you can solve 5D equal to 7D minus 7000. So D is equal to 3500 or 3.5 kilometers. So total distance would be 3.5 kilometers. The bike in front will be, the slower bike will travel 2.5 kilometers. Now, you don't need to do all this. We did this just to show the concept, but we don't need to do this. Relative speed is what you should use. So what we mean is by relative speed is the bike which is behind is going to close in on the bike which is ahead at a rate of 10 meter per second, right? So it is traveling at 35, the bike in front is traveling at 25. So the relative speed is 10 meters per second. So it is closing in on it at 10 meter per second, and the distance it needs to close in on is 1 kilometer, right? So how much time would it take for it to get to B2? That would be 1000 meters it needs to cover, and the speed at which it is covering is 10 meters per second. So in 100 seconds, it will be alongside B2. And from the question, we know that in 100 seconds, that means that in 100 seconds, they reach their destination. So using that, you can very quickly calculate the distance is equal to speed into time. So in 100 seconds, the slower bike would have traveled 25 into 100 or 2.5 kilometers. Okay, so sorry, it's not D, but the slower bike would have traveled 2.5 kilometers. So that gives us the concept of relative velocity, and we'll go in that. So what do we mean by relative velocity? And a lot of you would have heard of it at some point or the other, but let's just quickly look at it also. So if two objects are approaching each other, one is approaching at V, the other one is coming at U. So although in general they seem to be traveling at V and U, but for somebody sitting here or somebody sitting on this particular vehicle, the other one would be approaching them at a speed of V plus U, right? Because they are moving in the same direction. So the speed will add up. They are not approaching each other at speed V or U, they are approaching each other at speed of V plus U. So for the gap between them is closing at a speed of V plus U. Same way, if I am traveling in the same direction, so one vehicle is traveling at a speed of V, another vehicle is traveling at a speed of U, then for somebody sitting in U, what would the speed of A appear to be? And that would be, you will have to subtract the speed of U. So if it is traveling at V, for somebody sitting in B, it would look like it is traveling at V minus U. And the extreme case of that would be if both things are traveling at the same speed, you would feel that both of them are still. And that sometimes you might have noticed also. If you travel in a train, you might notice that both the trains are in fact still or traveling very slowly. But what might be happening is that they are traveling at a very high velocity, but the velocity is fairly close to each other. Aditya mentions H.C. Verma. Yeah, we won't go into that much of detail, as in we won't use vectors and stuff to identify relative velocity, but this much is helpful for us. So let's see questions, and that would make it clearer. But for example, if I am traveling at 10 meter per second and a vehicle is traveling towards me at 40 meter per second, and the gap between us is 100 meters, we are approaching each other at 50 meter per second. So we know that the time it would take us is 2 seconds. In 2 seconds, we would be face to face with each other. Same way, if I am traveling at 10 meter per second and another vehicle is traveling with me at 20 meter per second, and I need to find out after what time will that vehicle be 100 meters ahead of me. So I know that the relative velocity of this vehicle is 10 meter per second, 20 minus 10. So for me, according to me, it's traveling at 10 meter per second. And if it needs to create a gap of 100 meters, then it would be 100 by 10, or 10 seconds it will take for it to create that gap. So this much is relevant for us. We also have those boat kind of questions that if you are in a boat and in a river, then the velocity adds or subtracts depending on which direction you are going in. If the stream is flowing in the direction of the boat, if the boat is going at V speed and the stream is flowing at U, then the velocity of the boat with reference to Earth becomes V plus U. And if it is the stream is flowing against the current is against the velocity of the boat, then the boat is flowing at V minus U. Now you can have other versions also. In place of boat, you can keep it on an escalator. You can keep it on a whatever. Where else? I think there was one more example in my head, but I just forgot. So whatever. Yeah, airplane flowing through the wind speed. That also you can do. That the wind is creating a drag or wind is supporting the airplane, and all those kinds will be there. So we'll look at questions fairly quickly. Yeah, so swimmer and all those things. Kushal is asking, please clarify about police and thief type questions. So I have those questions. Those also come under relative velocity. I think I have one, or I might not have one also. If I don't have, I'll include it in the next class. So don't worry about it. But I have one of the type which you are thinking. So we'll cover that. Let's do some of the easier ones. Train is traveling at 30 km per hour. Another train starts at 60 km per hour and is 300 kilometers behind A. So A is going at 30 and B travels at 60. And there is a gap of 300 kilometers between them. Okay. How much time would it take for the second train to catch the first train? So if both are moving in the same direction and A is ahead by 300 kilometers, so we know the relative velocity. The one behind is at 60, the one in front is at 30. So the relative velocity with which B is catching A is 30 km per hour, and it needs to catch or cover 300 kilometers. So the time it will take is 300 by 30 or 10 hours, right? How much time? So it will take it 10 hours. Now, if both were moving in the same direction, so I'm traveling at 60, the one in 30 is also traveling in the same direction, and the distance to be covered is 300 kilometers. Then in this case, the velocities add, both are approaching each other at 90 km per hour. So the time that will take is 300 by 90 hour or 10 by 3 hour. Okay, 3.33 hour. So all this should be straightforward. Just exposing you to them so that you don't forget, don't make any mistakes and so on. Okay. Let's look at this one. A, B, and C travel in the same direction. So A is traveling at 30 kilometers per hour. B is traveling at 40 kilometers per hour. And C is traveling at 60 kilometers per hour. Okay. B starts 2 hours after A. So A has a head start of 2 hours. Okay. A is a head start of 2 hours. And B and C both overtake A at the same time. So how many hours after B did C start? Okay, so that's the question. So let's check how much head start A had over B. So in 2 hours, A would have covered 60 kilometers, right? In 2 hours, A is ahead by 60 kilometers. A is ahead by 60 kilometers. So B needs to cover 60 kilometers to get at par with A. And the relative velocity of B with respect to A is, velocity of B with respect to A is 40 minus 30 or 10. So it's covering at 10 km per hour and it needs to cover 60 kilometers. So the distance, the time it will take is 60 kilometers by 10 or 6 hours. So in 6 hours, B is able to cover the head start that A had and reach A. Now, how much distance would B would have traveled in 6 hours? In 6 hours, at its speed of 40, it has traveled 240 kilometers. Right? So B has traveled 240 kilometers. So if C has to reach at the same point, C also needs to travel 240 kilometers, for which it would take 4 hours. 240 by 60, 4 hours. So C needs to travel only 4 hours. B needs to travel 6 hours. So C can start 2 hours after B. B plus 2. Right? If this is not clear, mention right now. If it's something very new to somebody, it might not be very clear, but I think most people have some idea of relative velocity. If it's not clear, I'm happy to go through it once more. What is happening is there are 3 vehicles. A, which is the slowest, B is faster, C is the fastest. A leaves 2 hours before B. So A leaves 2 hours before B. Okay. And then B starts. And at some point, B catches with A, which will happen, right? If the faster vehicle starts, it will at some point overtake the slower vehicle. What the question mentioned is at that same point of time, C has also reached A. Now C is even faster than B and A. So she would probably have started even after B started, right? Because they are all reaching at the same point. We have been asked how many hours after B started did C start. So how will we calculate? We say A started 2 hours before B. So when B started, A had a 60-kilometer head start, right? It was traveling at 30 kilometers for 2 hours. So A was ahead of B by 60 kilometers. So there was a 60 kilometers gap. But B is 10 kilometers faster than A, the relative velocity that B has, which is 40 minus 30 equal to 10. So B is 10 kilometers faster than A. So every hour B will keep coming closer to A by 10 kilometers. So in 6 hours, B will be able to bridge this gap. So if they started at 10 a.m., by 4 p.m., B would have been just neck to neck with A. And that we got by 60 kilometers, relative velocity of 10. So it got 6 hours. So in 6 hours, B has reached A. This is relatively, but on absolute value, absolute basis, B has been traveling at a speed of 40 and A has been traveling at a speed of 30, right? B has been traveling at 40 for 6 hours, or it has traveled 240 kilometers. Similarly, A has been traveling at 30 for actually 8 hours because it started 2 hours before B did. And A has also traveled 240 kilometers. That's why they are neck to neck. So now if C has to be neck to neck at the same point, C would also have traveled 240 kilometers and C's speed is 60. So C needs to travel only for 4 hours to make the same distance. So if A has traveled for 8 hours, B has traveled for 6 hours, C needs to travel only for 4 hours, which means C can afford to start 2 hours after B started. And that's how we get that C will be 2 hours. So B will be A plus 2 hours. Whenever A started, B started 2 hours after. And C started 2 hours after B or 4 hours after A. Okay. If you still don't get it, try and doing it yourself. That will make it even clearer. So I have gone through it twice. If you listen to it and try and attempt it again, it should become much more clearer. This is just an introduction of the boat kind of questions. We'll do more difficult ones next session, I assume. A boat is there. It can travel with a speed of 13 kilometers per hour. Okay. In still water. And the speed is 4 kilometers per hour. Okay. Of the stream. When they mention downstream, they mention with the stream. It mentions with the stream. When the question mentions upstream, it means against the flow of the stream. So in English also, it's there are phrases like that. It seems flowing upstream or tailwinds and headwind kind of a thing. So if your vocab is not that good, you should look into that. What does headwind mean and what does tailwind mean? Tailwind meaning wind which is supporting me. Headwind means wind which is opposing my progress. So you can say that like that growth in Indian tech firms are supported by the tailwinds of rising internet penetration or those kinds. So it's again the same concept. I'm just digressing to a different topic, but so what we mean here is the boat is at 13 km per hour, the stream is at 4 km per hour. So what will the actual speed of the boat be? It will be 13 plus 4 equal to 17. Okay. If it had been moving in the opposite direction upstream, it would have been 9. And then if it is going 68 kilometers, it has to travel 68. It will just do 68 by 17, or it will take 4 hours for it to travel. So that's it. The question is easy. I just had it here to explain the concept. If you are so keen on answering the questions, this might be the one you want to look into. This I think is slightly trickier. No, it's not very tricky, but so it says this. Boat is traveling 60 kilometers upstream and 100 kilometers downstream in 8 hours. and then travels 75 kilometers upstream and 175 kilometers downstream in 12 hours. What is the speed of the boat in still water? Okay. So let's assume कि boat's still water speed is equal to u and stream speed is v. Okay. So when it is going downstream, so 60 kilometers upstream. So upstream the speed will be for the boat will be u minus v, and downstream it will be u plus v from what we saw. Okay. Now it takes 8 hours for it to go 60 kilometers upstream and 100 kilometers downstream. So speed is equal to distance by time, time is equal to distance by speed. 60 upstream divided by speed upstream, u minus v, plus 100 downstream divided by u plus v. This is equal to 8. And same way for the other case, 75 upstream, so 75 by u minus v, plus 175 downstream, 175 by u plus v is equal to 12. Okay. So now you have two equations, two variables. You can solve for them. Won't be very easy solving. It's some sort of a messy equation. You have u minus v, u plus v both in the denominator. So it's not very convenient to solve. I generally prefer, if I can see through this far, and when you are practiced, you should be able to. I would just assume the upstream and downstream velocity. So my equations won't be this. What I would assume is that upstream it travels with, say, so this is method 2. This is method 1, where you have got two equations in two variables and you can solve them to get the answer. What I'll do is upstream is equal to A, downstream is equal to B. Then doesn't make much of a difference, but the equation becomes more simpler to solve. They become 60 by A plus 100 by B equal to 8, and 75 by B plus 175, 75 by A plus 175 by B equal to 12. And then when you get A and B, then you can substitute A as u minus v and B as u plus v and solve to get the answers. Okay. In this case, at this stage, you can even try looking at the options and just seeing which one fits. That might save you some effort, which equation fits. Otherwise, you'll have to solve, which might be a bit more painful. So, but not very difficult conceptually. After that, this is a bit of algebra, which you can do or you cannot do. If you cannot, then you should go and do a bit more of algebra. Let's look at this one. We will do circular motion in a lot more detail in the next session. This is just a bit of a flavor. So don't think this is everything that we have to do on this topic. But let's see. There is a circular track and A runs clockwise at 6 pi meter per second. So A starts and runs at 6 pi meter per second. 6 pi basically means 6 pi meter per second. Okay. And B runs counterclockwise at 4 pi meter per second. So B is here and it runs at 4 pi meter per second. The radius of the circle is 36 meters. After what time will they meet for the first point? For the first time, I think it should be. After what time will they meet for the first time? Okay. So first question is when will they meet for the first time? And so that you can see the entire distance, the circumference of this is 2 pi r, or 2 pi into 36, 72 pi, right? And the relative speed. So now they're moving opposite to each other. Here again, relative speed is useful. And that's why I've included this, and we'll see a lot more of it in the next time. They're moving opposite to each other. So they're running away from each other at a speed of 10 pi meter per second. You can also use running towards, but it's fine. So in fact, that might actually be either way you look at it. So they're running towards each other at 10 pi meter per second, or running opposite to each other from 10 pi meter per second. Doesn't matter. So the relative speed over here is 6 pi plus 4 pi, or 10 pi meter per second. And they need to cover the entire circumference either this guy or that guy. So how much time would it take? Will be the distance by speed. So 72 by 10, pi gets cancelled. 72 pi by 10 pi, or 7.2 seconds. So in 7.2 seconds, they will meet for the first time. Where they'll meet, also you can say how much distance this guy would have traveled. It would have taken him 7.2 seconds, and it's traveling at 6 pi meter per second. So 7.2 into 6, or 43.2 6 pi. 43.2 pi is the distance that A would have traveled, and 72 minus 43.2 is the distance B would have traveled. So that you can calculate. The second question asks, after what time will they meet at the starting point? So that's a separate question. What time will they meet at the starting point? So let's look at that. The distance that the circumference is 72 pi, and the speed of A is 6 pi. So in making one round, A takes how much time? 72 pi by 6 pi, which is equal to 12 seconds. So A is back at the starting point in 12 seconds. B is back at the starting point in 18 seconds. Okay. B is back at the starting point in 18 seconds. So A will be at the starting point at 12, 24, 36, and so on. B will be at the starting point at 18, 36, 54, and so on. So after 36 seconds, they would be meeting at the starting point. Okay. So yeah, so you can take the LCM and you get 36 seconds. One thing, also think of that question. I didn't put it that way, but if I had written that they meet after 36 seconds for the first time at the starting point, would you have been able to do the back calculation? It's fine, I'll put in a question that way. That way it would be much more clearer. Maybe we'll put it in some of the quizzes or tests. Next question. Two trains start from A and B respectively towards each other at 8 a.m. If the train reaches B at 12 noon while the train going towards A reaches its destination at 2 p.m., what time do they cross each other? So there are two trains, A and B. So both start at 8 o'clock. The one going towards B reaches its destination at 12 noon. And the one going towards A reaches at 2 p.m. So we have been asked to say at what point do they cross each other? When will they meet? So you can do it in various ways. The distance is constant, and the time if the first one takes is 4 hours, and what this one takes is 6 hours, right? So the first one takes 4 hours, this one takes 6 hours. So given that distance is constant, the speeds will be in the ratio of, so as we have noticed, speed is inversely proportional to time given distance constant. So if timing is 4:6, the speed will be in the ratio of 6:4. Or if this one is at 6x, the train going from B to A is at 4x, which makes sense. This is traveling faster. That's why it takes only 4 hours. This travels only at, it just takes 6 hours because it's slow. So at what time do they cross each other? So a train from this side is traveling at, let's say, 6x. A train from this side is traveling at 4x. So the relative velocity of theirs is 10x, okay, because you can add them, 6x and 4x. And what is the total distance that they have to travel? The train traveling at 6x takes 4 hours to travel. So the speed is 10x, and the total distance is, the 6x train takes 4 hours. So the total distance in x terms will be equal to 24x. And hence, the time that it will take will be distance by speed, or 24x by 10x, or xx gets cancelled. It becomes 2.4 hours. So after 2.4 hours, they will be crossing each other. At to which point you can calculate at what point also do they cross each other. Is it clear or is it not clear? Just wait for a minute and drink some water while you think over it. I'm getting it's clear one. I've got one doubt also how 24. So let me go through this once more and so that it becomes very clear. We have it at 48 minutes. So I think we have covered a lot. If we are not able to cover a bit, we can do it in next session also. A and B. One train starts from A at 10, reaches at 12. Another starts from B at 8 and reaches at 2 p.m. Okay. So what we know first is this: given the distance is constant, S1 by S2 will be equal to T2 by T1. Okay. Now, since the one from B to A takes 4 hours, so if we do it like that, 6 hours, so the ratio becomes 6 by 4 or 3 by 2, you can assume. So the ratio of speed of the train going from A to B and B to A is 3:2. So if I assume that the train going from A to B is traveling at 3x, the train going from B to A will be traveling at 2x. Makes sense? Lower speed for the train which takes higher time in the same ratio. So what would be their relative speed at which they approach each other? So at 3x this one is approaching, at 2x this one is approaching, so they approach each other at 5x. So the speed at which they approach is 5x. And how much distance do they need to cover? The distance is this entire distance, right? This entire distance. And we can use either of the speed to calculate that. We can use this speed. The train traveling at 3x takes 4 hours. So the distance will be 12x. Or we can take the train traveling at 2x, which takes 6 hours. And the distance will be again 6 into 2x, 12x. So the distance is 12x. And therefore, the time taken will be equal to distance by speed, or 12x by 5x, which is equal to 2.4 hours. So it's independent of the distance. And once you assume, you know it's independent of distance, you can even assume some distance. So let's look at another method to do this. We need to be careful. Don't assume where you cannot assume, but if you are able to, it makes things even easier. Let's see. Given the numbers are 4 hours, 6 hours, I assume a good number. Let's say I say the distance is 360 kilometers. Let's assume the distance to be 360 kilometers. So the train which takes 4 hours, that is traveling at 360 by 4 or 90 kilometers per hour. And the other train which takes 6 hours is traveling at 360 by 6, 60 kilometers per hour. So they are both approaching each other at 150 kilometers per hour, right? Because 90 and 60, and the distance they have to cover is 360 kilometers. So the time it would take is 360 by 150 or 15 by 36, and you can cancel and you'll get to the same number, which is 2.4 hours. So since it is independent of distance, you can assume a distance and make the calculation much easier also. However, be careful, you don't start assuming distances where you cannot. And the best way to see you need to have a feel for where the information that you have been given doesn't refer to any particular distance and can be any generic distance. So we just assumed it. In this question, we have changed it a bit. Two trains start from A and B respectively towards each other at 8 and 9 a.m. So they're not starting at the same time. So what has changed now is one starts at 8 a.m. and reaches at 12. The other starts at 9 a.m. and reaches at 2. So now you need to know at what point do they cross each other. Calculation again, everything would be same. You can still do everything. The only thing you have to say is in this case it would have already covered d by 4 because it takes 4 hours. So it has already covered d by 4. So the only distance it needs to cover is 3d by 4. Here again, you can use both methods, but you can even assume distance. So let's just assume the distance again, and that way we'll do it fairly quickly. So we assume that the distance is 360 kilometers. Okay. So the first one travels at 90 kilometers per hour. The faster one travels at 90. The slower one travels at 60. I want to go through this quickly just to show that you can do it fairly quickly. 60, 90. They approach each other at 150 kilometers per hour. Right. But by 9 p.m. It has already covered how much? The 360 by 4 on 90 kilometers has already been covered by the faster train. So it needs to cover, they both need to cover only 270 kilometers. So the time it would take is 270 by 150 or 9 by 5 or 1.8 hours, and 1.8 hours starting from 9 p.m. So if you had to mention the time, it will be 9 plus 1.8 hours, or it will be 10.8 hours. So 8 hours, 0.8, don't make a mistake here. 0.8 means 8 by 10 into 60 minutes or 10 hours, 48 minutes. Now I've done this fairly quickly because I want you to be able to do this fairly quickly. You should not be, you should be able to do this in 1 minute or 90 seconds. And if you are not able to follow right now what I was doing, what it means is you need to spend time on it, go through the video again, write down what I have been writing, and then you will start getting the grasp of it, and you will be able to do these things quickly in the exam also. 10 and 48. So this is basically 10:48, not 10 hours 48 minutes. It's basically at 10:48 they will cross each other. Clear? So this is the same question, I think. No, this is a different question. Okay. So here is the police and thief question that some people were asking about. I think it's fairly similar to this one. So what it says is, and it's a very popular question, you might have come across it in various other places. Two trains are traveling towards each other at 60 and 40. So there is a train here which is traveling at 60 kilometer, and there is another one which is traveling at 40 kilometers per hour. Okay. So these two trains are traveling, and they are a distance of 1000 kilometers. Now there is a bird which starts from here. It's faster than both the trains, so it's at 100 kilometers per hour, 80 kilometers per hour. It's at 80 kilometers per hour. It reaches till the other train, then comes back, and then when it touches this train, it goes back towards the other train, and so on. It keeps flying between them till they collide. Right? So how do you know how much time will it take? Now, if you look at it for the first time, it might be very complicated, because thinking through it is very complicated if you do it for the first time. But once you know how to solve it, it's a fairly straightforward way to do this question. And most people may not be able to do it for the first time, but after they've seen it once, they know how to do it, and they just go ahead and do it. So the two trains are approaching, their relative speed is 60 plus 40 or 100 kilometers per hour. Okay, 100 kilometers per hour. There are a distance of 1000 kilometers. So the time that they will take will be distance by speed, or 1000 by 100, or 10 hours. So they'll take 10 hours to collide, and the bird will be flying for those 10 hours, right? We don't care which direction, what it has been doing, but the bird is flying for those 10 hours. So the total distance that the bird will have covered is 80 kilometers per hour into 10 hours, or it would have covered 800 kilometers. So this is not very difficult to solve. If not clear, again, raise your voice. But otherwise, what we are just doing is they're approaching each other. We know what time they will take to collide. They will take 10 hours to collide. And we know that the bird keeps flying for those 10 hours because either in this direction or in that direction, its length shortening, but it keeps flying. So the total distance it will travel becomes its speed into the 10-hour time that it has been given. And it becomes 800 kilometers. So the next topic we want to cover is average speed, but I think I can see some interest and uh, stamina reducing at this stage. So do we want to do this today or we can do it? We can do it in the next class also. I think I'll stop here for this one. We'll do another 1 hour session next class. Next class we don't have a lot to cover. Just average speed and clocks and circular motion, which we'll do in half an hour, and the last 40-45 minutes will solve a lot of questions on speed, distance and time. And post that we'll have our Facebook sessions anyway, where we'll do a lot of more questions. But I think, but just I'll give a teaser. I think most of you know anyway, but if I travel from A to B at 90 kilometers per hour and B to A at 60 kilometers per hour, my average speed is not equal to 75 kilometers per hour. This at least you should remember. If you want to calculate the average speed, calculate total distance by total time. In which case, in this case, if you had the total if the distance is d, if the I'll come to your question, Pranendu. If the total distance between A and B is d, then your distance becomes total distance is 2d, and total time becomes distance by speed. So d by 90 plus d by 60. Okay, and then you cancel d, so it becomes 2 by 2 into 90 into 60 plus 90 plus 60. Some people have learned it as a formula also. It's not very needed. You can do this on the fly. So, and this becomes whatever 150. So 2 and 5, 18 and whatever, 18 into 4, 72 kilometers per hour. So the average speed is 72 kilometers per hour. It's not 75 kilometers per hour, which might seem obvious, but once you know that, please do not make this mistake. In fact, you can actually complete. Okay, let it be. I'm very tempted to go through this again, but I think there are 1 or 2 tricky ones also at the end. So we'll do this in the next session. Thanks for attending. Panendu, you're asking if the boats were traveling in opposite direction, then also same way. You're asking in place of train, there were boats traveling. Is that what you are asking? If boats are approaching each other and the bird is flying? Because I didn't get your question. Mention the entire question and I'll respond to it. I didn't get your doubt right now. But we'll close here. Thanks for attending, and if you have any feedback, great. Apologies, we had a technical fault also in between for 4 or 5 minutes, but hopefully it wasn't big and we were able to continue. Thank you.